Welcome, dear students. Welcome to the Medical Globe. This is Dr. Hadi here. Students, we will discuss today the classification of carbohydrates. We have just discussed the detailed concept of carbohydrates in the last lecture, but in today's lecture we will discuss the classification. Dear students, the classification of carbohydrates is a little bit lengthy, so we will divide this topic into two parts: part 1 classification and part 2 the classification. In part 1 we will discuss the classification of carbohydrates, but the more time will be given to the first category of monosaccharides. However, these two categories will be just give a slight touch, and these two will be discussed in the next coming lecture, but our focus will be on this first category only. So the lecture will be so wonderful and you would like it. And definitely let's start that topic today. Carbohydrate classification. We classify carbohydrates in 3 categories. The names are mentioned on the whiteboard. The first category is called as monosaccharide, second one oligosaccharide, and third one is polysaccharide. In order to understand the classification of carbohydrates, we must know the hydrolysis, because this is the word hydrolysis that will help us to understand the definition and the concept of these 3 types of carbohydrates. So what is hydrolysis? If I tell you hydrolysis is a word like this, hydrolysis, and we see here we can split this whole word into 2 parts. One is hydro. Hydro means water. Every student can easily understand hydro means water, and lyse means split. Okay, split, you can say breakdown. So if we get the complete meaning of the hydrolysis, so it will be water splitting, water breakdown. But here you will not be able to understand, to get the idea clearly. Actually, hydrolysis mean there is one more thing in between these two words, water and splitting, water and breakdown. There is one more thing in between these two, that is any substance. If I just word this word substance. Now, breakdown of a substance by the help of water. Now it gives us a clear concept. So now if you break something with the help of water, this process will be called as hydrolysis. Coming into a little bit more detail, what are the things that can be broken down by water? The door, glass, stone. What else? Actually, in hydrolysis we will discuss on a micro level. We are going to break very small molecules, very small substances with the help of water. We cannot break large size thing with the help of water. So here the breakdown by the help of water is actually any small molecule. Let's suppose here is a molecule. I will write this is a molecule. Let's suppose this is a molecule, right? Okay, this is a molecule. I'm just writing as 2 circles. Let's suppose this is a molecule. And one circle you can consider it is an atom, and this is another atom. So we have 2 atoms, and these 2 atoms are connected by the help of a bond. So this is a bond. Now I want to break this molecule. This is a molecule. A molecule is something that is made of atoms, right? So let's use a molecule. and there is a bond between the atoms. Now I'm going to break it. So if we provide H2O, water, with the help of water, these two circles will be separated like this. And now look, we still have the two atoms, but there is no bond. So these two atoms are separated, the bond has been broken down, and this is because of water. So this is a concept of hydrolysis, a very simple concept of hydrolysis, right? Now, if I tell you something more, that a little bit more, that how water molecule breaks this molecule, it is actually H2O. If you see deep inside water, not inside water, if you see deep inside one molecule of water, you will find that water consists of two molecules. One is the OH and other is the H. Two parts, as will be more good to say, two parts. H2 consists of two parts. One is the hydrogen, usually H plus we write, and the second one is the OH minus. So what will happen? OH will be given to any one atom, and the H will be given to another atom. In this way, OH comes here and H comes here, and now the bond is broken. This was a simple diagram. Now you can easily say that this was hydrolysis. Now I would like to tell you, I will replace the circle by the atoms. Let's suppose we have carbon. Let's suppose this is a molecule where one carbon atom is attached to another carbon atom and there is a bond. Now if we add H2O to this molecule, what will happen? H2O consists of two parts. One is the OH and the other one is the H. So the OH will be attached here to this carbon and the hydrogen will be attached to this carbon. As a result, what will happen? One carbon will be separated from another carbon. This OH and here H will come. So this was just an idea how a molecule is broken by the help of hydrolysis. For me it is very important to tell. Otherwise, most of the time when we teach this topic to the students, we usually neglect the idea, the concept of hydrolysis. Without hydrolysis, the classification is very, very difficult. That's why I took some time to give this idea to you. I hope many students already got this idea of hydrolysis, but there are still I always call malang students, that they don't know about some basic things, because I'm going to help them and so that they could understand. Okay, after hydrolysis we will come now to the classification here. Carbohydrates is classified into three categories. The first one is called the monosaccharides, the second oligo, and the third polysaccharide. If you come to the monosaccharides, what is mentioned here? A monosaccharide is that carbohydrate which cannot be hydrolyzed, This is something that most usually makes students a little bit feel confusion, right? Cannot be hydrolyzed. What is mean by this? Cannot be hydrolyzed means they are already simple. They are already simple. They are already simple. Simple things cannot be broken down further if a molecule is already simple. Look, the example is these circles. These are the small circles. These small circles cannot be hydrolyzed, as I told you earlier, that when there is a bond between the two circles, it is a bond between the two circles, then there is a possibility that these two can be separated with the help of water, but these two circles are already separated. There is no bond, so we will say that these small circles represents monosaccharides because there is no bond between the individual circle. So one circle, you can call one circle as one monosaccharide. You can call it one monosaccharide. You can call it one molecule, right? You can call one circle as a sugar. All up to you. You can call it the one circle monosaccharide or a molecule or a sugar. So this is also a monosaccharide or a sugar. This is another molecule or monosaccharide or sugar. This is another. So these are all monosaccharides which are separated from one another. So in such case, you cannot hydrolyze them further. Dear students, we will come back here. We will explain monosaccharide in more detail. We will study some more points about the monosaccharides. You must wait for 3 to 4 or 5 minutes, because I will tell some succinct idea of these two, and we'll come back. Now, oligosaccharides. What are oligosaccharides? Oligosaccharides are those carbohydrates which can be hydrolyzed, just as it is mentioned here, which can be hydrolyzed. Dear students, the classification is based on the hydrolysis. Look at that. You can see here, we can see the word hydrolysis. So can be hydrolyzed, and when it is hydrolyzed, it will give us 2 to 10 monosaccharides. I'm happy because you know very well already that what are monosaccharides. So here is one circle connected with another circle. Here we can see there are 2 small circles are connected with the help of a bond, and here we can see there are 3 circles, and even you can write there are 4, 5, 6, 7, 8, 9, 10, right? But the last limit is 10, right? The last limit is 10. In this category, these molecules can be hydrolyzed because one circle connected with another circle. There is a bond between the 2 circles, so we can easily hydrolyze them, right? In this category, you cannot call them a monosaccharides. In this category, you will call it oligosaccharides, right? But remember, if it is oligosaccharides, it contain from 2 to 10 monosaccharides. From 2 to 10 monosaccharides. Means maybe there are 2 monosaccharides attached, or 3 monosaccharides attached, or 4, 5, 6, 7, 8, 9, 10. 10 is the limit. Up to the 10 monosaccharides are possible, and they can all call that oligosaccharides. About 10 monosaccharides, we will give them another name of polysaccharides. So 2 circles, you can call it 2 monosaccharides attached. If I add H2O, and definitely these 2 will be separated, and these 2 will be separated like this. Okay, yes. Now these 2 monosaccharides are separated. Okay, because hydrolysis occurred. Now here, these are the 3 circles. These are 3 monosaccharides attached. If I provide water, with the help of water, these 3 circles will be separated, right? So in this case, we will get 3 monosaccharides after hydrolysis. In this case, we will get 2 monosaccharides after hydrolysis. And in this case, you can tell me, if I add water, how many monosaccharides can we get? We will get, if these are 6 circles, so we will get 6 monosaccharides, and in case of 10 we will get 10 monosaccharides. So all these, not one, all these are collectively called as oligosaccharides. Further, oligosaccharides can be given more names, can be given more subheadings. Within oligosaccharides, we can find, we can see names like disaccharides, disaccharides. Okay, don't worry, what is disaccharide? If a carbohydrate after hydrolysis give us 2 monosaccharides, because here is di means 2, so if after hydrolysis it gives us 2 monosaccharides, we will call it disaccharide. And don't worry about the word saccharide. A saccharide always mean sugar, and a sugar, you can also call it monosaccharide, as I already told you that each individual circle can be called a monosaccharide or a sugar. So 2 monosaccharide, disaccharide. After hydrolysis it will give us 3 circles. So we will call it a trisaccharide, and if carbohydrate after hydrolysis give us 4 circles, it will be called tetrasaccharide, penta, hexa, up to the 10. In our course, the most important oligosaccharides is this one, the disaccharide. I am going to put a star over it. The most important is the disaccharide, right? The disaccharide is the most important. So now I'm going to erase this. And as I told you that we will come to this topic in my next lecture. I'm just going to give you some examples of the disaccharide. These examples are lactose, maltose, and sucrose. In the next part, lactose, maltose, sucrose will be discussed with the help of structure, right? With the help of structure, these will be discussed. And now come to the polysaccharides. You will understand the idea of polysaccharides now very easily. What is polysaccharide? If a carbohydrate after hydrolysis give us more than 10 monosaccharides, right? More than 10 monosaccharides, it will be called a polysaccharides. So it can be 50, it can be 100, it can be 200 and 300. So usually a diagram will be like this. Okay, a diagram will be like this. I think, yes. A lot of small circles you can see. Every circle is a monosaccharide. You must watch this video till the end in order to understand the real structure of this circle. I will write the original structure of this circle, what the circle actually is. But up till now, each circle is a monosaccharide, right? So lot of monosaccharides are attached. In this case, it will be called as a polysaccharide. You can see maybe it is open chain or like this straight chain, right? So straight chain, and maybe you will see here is a branch here, a branch. You maybe see a branch here. You can see a branch here. So in this case, such carbohydrates, we have a lot of carbohydrates in this form. This kind of carbohydrates will be called as polysaccharide, because here the word poly means many and saccharides means sugar. So we have many sugars attached with one another. This will be called as polysaccharide. What is example of the polysaccharide? And the example of polysaccharides are number one, glycogen. Number two, starch, right? Number three, cellulose. According to the promise, in the next part we will study glycogen, starch and cellulose. But don't worry, I'm going back to the monosaccharides. Glycogen is the one that is stored in the liver of the human and other animals. Starch is the carbohydrate that is stored in plants, wheat, rice, okay? Cellulose is the carbohydrate that you will find them in the cell wall of the plant. Cellulose, right? So now come back to the monosaccharides. I think we now don't need the oligosaccharides further. So here is, I'm going to erase this all for you people. Okay. So if I just remind what was monosaccharide, so you will tell me a type of carbohydrate that cannot be hydrolyzed. That means that these are already simple. So what are the other points associated with monosaccharides? What more points we have? If the question comes in exam, how we will write about the monosaccharides? What will be the points that will help us to write something on the page, on the sheet? About monosaccharides, we have second point, that their formula is, their general formula, the general formula of the monosaccharide is CnH2O bracket closed, and here we write N. This is the formula of monosaccharides. What is mean by this formula? This formula means that monosaccharide contains carbon, they contain hydrogen, and they also contain oxygen. The first thing that we must know, that all monosaccharides contain carbon, hydrogen and oxygen. Second, what is mean by this N? N is just a number. It is just a number, right? You can see it is 1, 2, 3, 4. It's O or U maybe. 1, 2, 3, 4, 5, 6. It may be any number from 1 to 7, right? So N is a number that can vary from from 3 to 7, right? Here in this case it may be from 3 to 7, means this N could be 3, this N could be 4, this could be 5, this could be 6, this could be 7, but it cannot be 8, 9, 10. As usually we see in math, N can be any number, but here in carbohydrate N can be 3 to 7, right? And this N is again the same number. So what it tells us is, actually it means that in monosaccharides, if there are 3 carbon atoms, the hydrogen will always be double the number of this. Means if 3 carbon, the hydrogen will be 6. Always, because this is the formula that tell us. Let's suppose in case of 3, if I write here 3, so you must write 3 here, because you say that N is equal to 3. So if you write 3 here, you must write 3 here. Now do on your multiplication. 3 with carbon, 3 ones are 3. Okay, 3 comes. Now this 3 must be multiplied with this 2, and it must be multiplied with oxygen as well. So there are 2 hydrogens, so 3 2s are 6. Here is 6. With oxygen you cannot see any number. Absence of any number shows there is 1. So 3 ones are 3. Look at that. Now this is one monosaccharide where 3 carbons are present, 6 hydrogen and 3 oxygen. So this is just a monosaccharide. It is just a molecular formula. It is the molecular formula of monosaccharide, of this one. Now if I write C4, if I write C4, because we are told already that carbon may be 3, 4, 5, 6 and 7. So if it is 4 carbon, and you will tell me how many hydrogen will be there. The double of 4 is 8, so C4H8, and O is always equal to the carbon. If 3 carbon, there will be 3 oxygen. So if 4 carbon, there will be 4 oxygen. It again follows the formula CnH2ON. So this is another monosaccharide. And now we have another monosaccharide C5. How many H would be there? You will say there will be 10 hydrogen, and how many oxygen? You will say yes, there will be 5 oxygen. So it is another monosaccharide which contain 5 carbons. And the last one, you can go further, but the last one is C6. There are 6 carbon, so how many hydrogen will be there? 12 and 6 oxygen. This one is the up to here. This is one monosaccharide, another. These are all monosaccharides, but there are different monosaccharides. One 3 carbon, 4 carbon, 5 and 6. The most important one are the one with 3 carbon, the one with 5 carbon, the one with 6 carbon. These 3 are most important monosaccharides that we will discuss. We will write their structure as well, right? Okay. I will write to draw their another formula. This was just which formula? This was this molecular formula of the monosaccharides. I will write another formula, that is the structural formula. Okay, here is the structural formula, right? What is the structural formula? In structural formula, we write the structure. We write a structure in such a way that bonds are shown. Okay, so let's start with this one. Those students who are watching the video now, I hope they have seen my last video lecture of carbohydrates concept, where we discussed carbohydrates in detail. What are carbohydrates? They contain aldehyde group, ketonic functional group. You know these things very well. I suggest you must go there, watch the first part of carbohydrate, and then come here, because you will stick here. You may not go ahead without that lecture. So structural formula. In structural formula, there's a point that in every monosaccharide, every carbon contain OH group. Every carbon contain OH group except one carbon which does not contain OH group. So this one contain OH group, this one also contain OH group, and this one, it will not contain OH group. It will be the part of either aldehydic functional group or ketonic functional group. You just don't worry what are these aldehydic and ketonic functional group. This is already discussed in that lecture. So it may be the part of this C double bond O and H. If double bond OH comes here, so we say this is aldehydic functional group. This is aldehydic functional group. So in every monosaccharides, every carbon contain OH except one carbon which does not contain OH. This is the first point. Now, this is a 3-carbon monosaccharide. The valency is complete. Here the valency is not complete, so we will write one hydrogen here. 1, 2, 3, 4 valency. This carbon has 2 valencies, so we will give 2 more hydrogens. Now it becomes 4. Usually we write CH2 here, CH2 here. Now this is a monosaccharide. This is the structural formula, and this one is the molecular formula. So this one, and yeah, this one. This is the molecular formula of the monosaccharide, and this one is the structural formula of the monosaccharides. You can see there are 3 carbon, 3 carbon. There are 6 hydrogen, 1, 2, 3, 4, 5, 6 hydrogen here, and 3 oxygen here. 1, 2, 3 oxygen on him. So right now, similarly, we can write the structural formula of this and this and that. But for your convenience, I will write the structure formula of this one, this monosaccharide, right? Okay, here we can see 6 carbon. So first of all, I will write 1, 2, 3, 4, 5, and 6 carbon, right? As I already told you that in monosaccharides, every carbon must contain OH group, except the last one, which shall not contain the OH, but it may be the part of aldehyde group or ketonic group. So I will just write here, double bond OH. Such kind of group always refers to the aldehyde. So this is aldehydic functional group. Now we have so many OH groups attached to the carbon atom. Dear students, in today's lecture, I am going to write the OH all on the right side, just for the convenience. But another lecture will come where we will take a lot of care while writing the OH. We will see the OH should come either on the right or on the left. So we will give slight focus on the incoming lecture, but not today. Today you are free, you are kings in today's lecture. You can write OH on any side. So here is a H, 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 and here H2, because valency problem is there. You cannot write 2H here, but here valency must be satisfied, so we are going to write 2H. Now again, this is another structural formula of this molecule. So this is another molecule. This is another monosaccharide which has the molecular formula C6H12O6, and this is the structural formula. This is one monosaccharide, this is another monosaccharide. You can see they contain 3 carbon, contain 6 carbon. My dear students, now finally we'll come to the initially point of my lecture. From the point where I started my lecture, I draw some diagram where you saw small circles were there. But now I would like to tell you that each circle actually represent these monosaccharide. So one circle may be this one or this one, right? If I say this is one circle, so mean this is one monosaccharide. This whole monosaccharide, if I write attach another circle, means this is one monosaccharide, this is another monosaccharide, and this is another monosaccharide. This circle was just to make sure that you people got my lecture, you understand the lecture. Now every circle is actually the structure. like this. Okay, and in the coming lecture we will make a bond between this structure and another structure. We will show you how the bond is formed between the two, but it will be discussed in the disaccharide and the polysaccharides. Okay, I hope you got my idea. Now this was done, and now the third point is about monosaccharides. Look, this was just the second point about monosaccharides. You can write so many points about monosaccharides on your sheet. Now I'm going to write some more points, but I will not erase this one. I can erase this one. Okay, so the third point is all monosaccharides are sweet in taste. These are, okay, point number 3, these are sweet in taste. I think I don't need to explain this. They are sweet in taste. You can check it. Glucose, you might have heard the word glucose. If you just take glucose from any general store, you can put some amount of glucose on your tongue and it will be sweet in taste. And third one, they form ring structure, right? They form ring structure. What does mean by this ring structure? They form ring structure. Ring structure means monosaccharide, as you can see, they are open chain, right? What does it mean by open chain? An open chain is like this, where carbon are attached like this. Okay, this is called open chain. You can write it like this. This is also open chain. You can go, okay, it's all open chain. But what does it mean by ring? Ring means that the first carbon make a bond with the last carbon, or the first carbon make a bond with the second last. Anyway, this is then called a ring. Okay, I will give you one more example. Let's suppose this is one carbon, that these are 3 carbon atoms, right? 3 carbon atoms are attached with one another. Now I'm going to this is the open form. Now I'm going to make it in the form of a ring. So this is one carbon, this is another carbon, right? 1 carbon, 2, 3 carbon. It is still open chain. I just make a bond here between the first and the last. Now it's called the ring form. The good news is that monosaccharides are in the open structure, but once you add them in water, they form a ring. They form ring, and the ring structure is like this. I will tell you here. In ring formation, what will happen? That the carbon number one can make a bond with carbon number 6 here, right? If I give numbering, this is carbon number 1, 2, 3, 4, 5. So carbon number 1 make a bond with carbon number 5 and a ring will be formed. How a ring will be formed? Just come here, I will tell you. Okay, here is the ring form. This is carbon number 1. This is carbon number 2, carbon number 3, carbon number 4, right? Carbon number 5, carbon number 6, right? Carbon number 1, 2, 3, 4, 5, and this is carbon number 6, right? Even you know that every carbon contain H and OH. Fine, okay, fine. Except the first one, which contain double bond O, right? So it's a double bond O. That is a double bond O. And here is the hydrogen. these contain HOH. I'm not going to write HOH, right? You know, HOH, 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 H, right? H, as is the second one, right? H. This is the last carbon, CH2OH. Okay, fine. So what will happen? Carbon number 1 make a bond with carbon number 5 with the help of oxygen. This is the oxygen, right? This is the oxygen, right? Is present here. And how it will happen that this bond on the carbon, it will be shifted towards the oxygen. It will be shifted towards the oxygen. And what will happen when the whole bond is shifted to the oxygen will get a negative charge. The oxygen will get a negative charge. Look, there were 4 bonds around the carbon number 1, but now there are 3 bonds around the carbon. So this carbon will become positively charged and that oxygen will become negatively charged. Now you come to the carbon number 5. You know that at carbon number 5 we have H and OH. So this is the OH, right? This is the OH, and here that is the hydrogen. Fine. Now what will happen when this happens? The H of the hydroxide ion, attached with the C5, this oxygen will kick off the hydrogen. We say, get off my place. So the hydrogen will be removed, and this hydrogen, definitely hydrogen, whenever it is removed, usually it is removed in the form of H plus. So it is kicked off. It is without electron, right? So without electron, it always contain H plus. So the H plus will be attached here and the negative sign will be removed. Okay, fine. Don't worry about this. Now the hydrogen is not there because hydrogen has gone. I think I would like to write H here so that you understand that this is the hydrogen that came from someone else. Okay, fine. So this is hydrogen came here. Now what will happen? This oxygen also contains negative charge. Fine. So negative charge oxygen will make a bond with this positively charged carbon. So a bond will be made between this one. Oh, what will happen? Is there any removal of an atom from this whole molecule? No. Atoms just changed their position. Hydrogen atom shifted from C5 to the C1. Nothing happened. Only this happened like this. So we still have 6 carbon, 12 hydrogen and 6 oxygen like this. This is now called the ring form, where C1 is attached to the C5 by the help of the oxygen atom. Now I will write a little bit easy structure of this. Usually we write this structure like this: oxygen, okay, like this. Yeah, this is the structure. Usually write is C1, C2, C3, C3, C4, C5 and C6. Yeah, we usually write the structure like this. Now see, OH is there, and at C1 we have OH, and here we have H. Of course C2, H and H are just like as they were in the open structure. So H, OH, H, OH, H, OH. At C5 you will see only H. The OH is here without hydrogen, and this is CH2H5. This is a very clear structure of the glucose. This one, C6H12O6. So this is a structure of the glucose, right? There's a kind of ring formation. You people are lucky. Of course, I'm also lucky that we today got the idea that how the open structure become a ring. in case of monosaccharides. Now coming to the this ring structure, once again I'm going to erase it like this. The ring structure may be 5 cornered, or it may be 6 cornered. 5 corner means you can call 5 corners as a few renos, and 6 corner you can call it pyrenos. Means if you have a monosaccharide having 6 corner like this, right? Here is oxygen. This kind of ring is called as, this is furenos, right? 5 corner. Okay, 1 corner, 2, 3, 4, 5 corner. If 5 corners are there, we call it furanose ring. And if it is like this, okay, now it is we call it 6 corner ring because there are 6 corners. Remember, only 1 corner has been shown as OOO, oxygen is there. All other corner contain carbon. Fine. So monosaccharides can make 2 types of ring, either 5 corner or 6 cornered. If it is 5, we call it furanose, and if it is 6, we call it pyranose ring, right? If I ask a question that this is glucose, so is it glucofuranose or glucopyranose? We will say it is glucopyranose. Okay, fine. Once we get monosaccharides in the ring form, we see one more idea of alpha and beta sugar. Now, what is mean by alpha and beta sugar? Alpha sugar and beta sugar. It is all about the OH on the carbon number 1. Look at that, it's carbon number 1. The carbon number 1 in this case, this is called as anomeric carbon. Which carbon it is called? Anomeric carbon. Okay, you just remember that in case of glucose, carbon number 1 is very lucky carbon. Why? Because it is that carbon which contain aldehydic functional group, and we call it the anomeric carbon. All the other carbons do not have such name except the 4th or 2. They are called as apimeric carbon, apimers, right? So apimer will come in the next lecture. The first carbon is called as the anomeric carbon. So looking at the anomeric carbon, looking at the OH, if the OH is above the plane, the OH is above the anomeric, we call it the beta. If the OH is above the plane, it will be called beta sugar, and if the OH comes down, H moves up, it will be called alpha sugar. So OH is below the plane. In this way, we got the monosaccharides structure wise. And now last thing, you will not leave the class, you will see the last thing is the classification of the monosaccharides. As I told you, the classification of monosaccharides is very, very lengthy. We cannot record this whole in one lecture. Now the classification of monosaccharides classification. Oh my god, we classified carbohydrates, and now we are going to classify monosaccharides. So monosaccharides can be classified into 2 categories, number 1, number 2. Number 1 is on the basis of functional group, and on the basis of number of number of carbon atoms. Okay. On the basis of functional group, the monosaccharides are two types. Number one, they are either aldehydic sugar or ketonic sugar. If a monosaccharide contain aldehydic group, means this one, C double bond O, at one side there is R and at another side is H. If a monosaccharide contain this kind of group, it is called as aldehydic group. For example, we have glucose. We have glucose, right? You know very well, this is the structure of the glucose, and C double bond O has H, and all the remaining part here, this is called as R. So R C double bond OH, this is aldehydic sugar, and its name is called as the glucose. What is the formula of glucose? C6H12O6. A ketonic sugar is the one where C double bond O has both sides, where C double bond O has R on its both sides. So an example of this sugar is fructose. The example of this sugar is fructose. The formula of fructose I have not mentioned, but I will write the fructose formula as well. The fructose formula is just like glucose, but there is only one difference. Come, at carbon number 2, you will find double bond O here, and at carbon number 1, you will find CH2OH, right? Now this one, this is now not a glucose, it is now called fructose, because on one side of C double bond O, oh my god, sorry, there is no hydrogen here, sorry. On one side of C double bond O, this whole structure is just one R, and on another side of C double bond O we have another R. So R C double bond R. This is ketonic sugar, and this is called fructose. If you count the number of carbon, if you count it, you will find there are 6 carbon, and there are 12 hydrogen and 6 oxygen. This is quite interesting. Fructose, glucose, both have same formula. Look, both have same formula. But what is the difference? Glucose is aldehydic sugar and fructose is ketonic sugar. The two sugars are the isomer of one another. We will discuss isomer as well, but it will help you in that lecture, inshallah. You just understand this. Okay, so this was one classification. So we will classify monosaccharide on the basis of the functional group. Second one, on the basis of number of carbon atoms, right? On the basis of number of carbon atoms, we can have some monosaccharides like triose, tetrose, and pentose, and hexose, and the last one heptose. The last one is heptose. Okay. Triose is that monosaccharide which contain 3 carbon. 1, 2, 3 carbon. As it is mentioned here. 1, 2, 3. This is a triose. It is a monosaccharide. If you see at this structure, from the functional group point of view, this is an aldehydic monosaccharide, and if you see at the number of carbon, this is a triose, 3 carbon. Tetrose, it contain 4 carbon. Pentose, it contain 1 2 3 4 5. Pentose, 5 carbon. Hexose, 1 2 3 4 5 6. Luckily, we have already discussed the structure of the hexose. This is a hexose. There are 6 carbon. So dear students, this structure, on one side it is a ketonic sugar, and another side it is a hexose. So my dear students, what if I call fructose as ketohexose? Ketohexose. What would you suggest to me? Is it right? Yes, fructose can be called ketohexose. Why hexose? Because there are 6 carbon atoms, and keto because there is ketonic functional group. So the name of fructose is also ketohexose. Maybe some of my students, they will give me the name of glucose. Can you find the name of glucose like this? Right? Write it in the comment box if you know. Okay. Most important ones are the triose. Most one of the like this. Like this is glyceraldehyde, right? 1 2 3. All right. What is the name of this? The name of this is glyceraldehyde. Glyceraldehyde. So this is a triose. We will not require tetrose, pentose. However, these two are most important. Pentose and hexose. These two are most important. I will give the name of these two as well. In case of pentose, we have wonderful example, that is ribose and deoxyribose These two are very good example of pentoses. Ribose is the part of the RNA, and you will have to wait for my lecture of the RNA. Deoxyribose is the part of the DNA. You will not wait for this because I have already discussed the RNA and DNA especially in detail in the same channel. So these two are the part of the RNA and DNA. Hexose, glucose, you know very well. Glucose is the main energy source of the body. We get energy from the glucose, so it will come from the hexoses, and heptose is not that much important. So dear students, finally we got all the idea in this one lecture. So I will just recall my whole lecture that today we discussed the classification of the carbohydrates. Carbohydrates are classified into 3 classes. Number 1, monosaccharide, oligosaccharide, and polysaccharide. These 3 were classified on the basis of the hydrolysis. Monosaccharide cannot be hydrolyzed, oligosaccharide can be hydrolyzed, and polysaccharide can be hydrolyzed. We discussed them, and then we discussed the properties of the monosaccharides, where we saw that monosaccharides have the formula CnH2ON. These are sweet in taste. They form ring. Ring is of 2 types, purine and pyranose ring. And then we also discussed that how an open chain monosaccharide is converted into a ring form. Most usually students get confused from this. And the last one is we also discussed the classification of monosaccharides. Monosaccharides are classified into 2 categories. Number 1, on the basis of functional group. Number 2, on the basis of number of carbon atoms. On the basis of functional group, we have 2 types of monosaccharides: ketonic sugar or aldehydic sugar. On the basis of number of carbon atoms, we have triose, 3 carbon monosaccharide, tetrose, pentose, hexose, and heptose. As I already mentioned, that in case of monosaccharide, you will find 3 carbon minimum and 7 carbon maximum. There will be no monosaccharide with 2 carbon. No. There will be no monosaccharide with 10 carbon. Monosaccharides are available in 3 carbon to 7 carbon. I hope you enjoy that lecture. Thank you. See you. Bye-bye.